Audio Jungle.
Hello everyone, let us discuss how the error is handled by the data link layer. We will take an example of Hamming code technique which is used to detect and correct a single bit error by the data link layer. For correcting a single bit error using Hamming code technique, we have to first of all calculate how many redundant bits are added to be into the message. Because if we want to detect or correct an error, then we have to add some extra bits that are called as a redundant bit along with the message bits. So as shown in the given example, here we have a message that bit as 110 So there are total 8 bits in the message. We have to follow a formula that m plus r plus 1 must be less than equal to 2 raised to r, where m is the number of bits in the message plus r is the number of redundant bits. You can say the parity bits also, or we can say the extra redundant bits. So the message will be of m message bits plus r redundant bits in such a way that this formula is satisfied. So we have calculated here that r must be equal to 4. We can take more than 4 also, but it is not necessary to add extra bits as it is increasing overhead while data transmission. Now the question is where to add these 4 redundant bits. So in a 12-bit message code, that is now our resultant Hamming code, we have to leave the places blank for the redundant bits or the parity bits as the positions which are power of 2. As shown in the figure, we can see here these are the positions where position 1, 2, 4 and 8 are kept empty and rest of all the positions are filled with the message bits in a sequence from left to right bits. Now let us understand how to calculate these parity bits that are the positions 1, 2, 4 and 8. So to calculate the parity bit at position 1, that is P1, we have just given name P1, P2, P3 and P4 to identify the position numbers. But the position is 1. So here we have to remember one thing, that we are calculating a even parity Hamming code. So the number of ones in a particular positions must be even. Let's say for example for position 1, which are the position need to be considered. So here we will consider position 1, 3, 5, 7, 9 and 11 for the even parity calculation. Now how to remember this position? So for position 1, start with 1, leave 1 position. So 1, leave 2 and take third position. Leave fourth one and take the fifth position. We will do it up to the number of bits into our message. That is, we have 12-bit message. So we have taken 1, 3, 5, 7, 9 and 11. Now we have to calculate number of ones and we have to make all these positions as a even parity. Number of ones are even, that is even parity Hamming code. Right now here we have kept dash for position 1 because we have to find out or calculate the bit to be kept at position 1. So rest of bits are 1 at position 3, 1 at position 5 and so on. So there are total 5 number of ones. So it is right now odd parity. So we will be adding 1 at position 1 to make all these positions even parity. Okay, fine. Now let us look at for position 2. So for position 2, start with 2, take 2 positions, leave 2 positions. That is 2, 3, leave 4, 5. Take 6, 7, leave 8, 9 and take 10 and 11. Now here the simplest technique is shown, that instead of calculating number of ones, you can simply add the bits you are getting at this given positions, and just do modulo 2 for calculation. So if you are writing a program for Hamming code, then this formula is most useful. So we are getting odd number of ones. Again, for position 2 we will keep a bit 1. Fine. For position 4, that is, now we are calculating third parity bit. So for position 1 we will start with 4, take 4 positions, leave 4 positions. So 4, 5, 6, 7. Now leave 4 positions, that are 8, 9, 10 and 11. Again we are left with one position, that is 12. So we have to consider 12 here. And there are two ones in these positions, that is at position 5 and at position 7. So they are already even. So we will add 0 at position 4. Similarly for position 8, that is the fourth parity bit, is calculated by considering positions 8, 9, 10, 11 and 12. We are not having more positions further after 12, so we have just taken 8 to 12, because right now we have to consider 8 positions, but we don't have more than 12 positions, so we have taken up to 12. So their number of ones are 2, that is even, so we will keep 0 at position 8. Now, when this data will be received by the receiving end, if there is an error, then how the receiving end will be able to correct the error. So we have constructed an Hamming code and sent, but at the receiving end, as shown in the figure, we can see there are errors at position 6. So this error, how it will be detected and corrected by the receiving end. On the receiving end, the same procedure will be done. That is, it will calculate for the even parity Hamming code. It will calculate the same uh, positions for 4 parity values, and if it is getting 0 means no error. If it is getting 1 means there is something error in that parity positions. So here as shown in the figure, the receiving end has calculated for parity P1, that is for position 1, and it is getting 0 because number of ones are even. But for position 2 and 4, it is getting odd number of ones, that is, it is getting error, as the 1 is the resultant value. So 2 and 4 positions are detected as error, and position 8 parity is perfect. It is given even parity. Now what to do with this number 2 and 4? So either we can add 2 plus 4, we will get 6 as the result, that is the 6th position is having the error. Here we can see that instead of 0, the receiving end has received 1. So now the receiver has detected an error at position 6. So it can correct it by removing 1 and will replace it with 0. Another way is that we can write a binary code for 4 bits, that is using 8421 coding standard of binary numbers, and we will write one where the we have the error, means at position 2 and 4 we have error, so we will write 1 1 there, and 1 and 8th position will be 0 0. So the binary code is 0 1 1 0, that is nothing but bit 6. Here are some examples for you to do more practice. Can refer this reference books for further study and examples. If you have any doubt, then feel free to contact me on the given address. Thank you. Stay home, stay safe. Goodbye. See you in the next session.